Today we are going to discuss about how we can measure the available micronutrients from the soil. The most common method which is used for the determination of extractable micronutrients from the soil is known as DTPA method. DTPA method is the diethylene triamine pentaestic acid test is commonly used for evaluating the fertility status with respect to micronutrient cations such as iron, zinc, manganese, copper. The DTPA method is an important and widely used chelating agent which combines with free metal ions in the solution to form a soluble complexes of metals. Uh, this is very important and useful methods for determining the micronutrient, particularly in the alkaline soil. The apparatus we need for this experiment is atomic absorption spectrophotometer, mechanical shaker, and the glassware. The reagents we need for this experiment are most important one is the DTPA extraction solution. Uh, how we can prepare this DTPA extraction solution I will show you in the video demonstration. But for to prepare DTPA extraction solution we need DTPA and calcium chloride. We need to mix them in a beaker. Uh, we need 1.97 gram DTPA and 1.1 gram calcium chloride and dissolve in distilled water and then transfer it to 1 liter volumetric flask. And we also need to prepare TEA, triethanolamine, um, weighing 14.92 gram or at 13.3 in the liquid form, transferred with the distilled water into a 1 liter flask and then bring it volume to up to the mark. And we will mix all these reagents and we need to adjust their pH exactly to 7.3 with HCl, 6 normal HCl. And this DTP extraction solution will contain 0.005 molar DTPA, 0.1 molar TEA, and 0.1 molar calcium chloride. We also need to prepare a series of standard solution for each micronutrient by using their respective salt. Here I'm going to demonstrate you about how uh, we need to determine the micronutrient from a particular soil. For this I already mentioned we need atomic absorption. The picture uh, you are witnessing here is of the atomic absorption spectrophotometer. This is very important instrument and through which we can measure all the micronutrients that I mentioned like iron, zinc, manganese, and the copper. We also need the electronic balance as well as we need uh, flasks different uh, the flask with different capacity and the volumes we need for the shaking purpose. We also need the pipette and we also be using the mechanical shaker reciprocal. And we also need the filter paper and the funnels, the bottles different for distilled water. Here before starting the experiment we must run the atomic absorption so it's be ready for for the analysis of different micronutrients. We also, as I already mentioned, we need different reagent to prepare the DTPA extraction solution. Triethanolamine TEA that I already mentioned. We also need to prepare this by adding 13.3 ml. I'm making its volume to up to mark to a 1 liter, and its concentration will become 0.1 molar TEA. That's how we are going to prepare it. We also need the pH meter because while preparing the DTP extraction solution, we need to adjust its pH. After mixing DTPA and calcium chloride and triethanolamine, and we must adjust its pH exactly 7.35. After adjusting the pH of DTP extraction solution, we need to prepare stock solutions of separate micronutrient. We need to prepare a separate stock solution for each micronutrient like iron, zinc, copper, manganese. We need to prepare a series of standard solution for each micronutrient. To prepare series of standard solution for zinc, we need to prepare a stock solution of 100 ppm. First, we need to dilute the 100 ppm stock solution and pipette 10 ml diluted solution into 100 ml flask, and then dilute to volume DTPA solution. This solution will contain 10 ppm zinc. Then pipette 1, 2, 4, 6, 8 and 10 ml in 50 ml numbered flasks and dilute to DTPA solution. These solution will contain 0.1, 0.4, 0.8, 1.2 and 1.6 and 2 ppm zinc respectively. So in this video you can see a different series of standard solutions for zinc are being prepared. The first 100 ppm is diluted to 10 ppm. To prepare the commercial, we can find the commercially available stock solution. 1000 ppm of stock solution can be purchased from the market, and you can prepare by yourself. Similarly, like zinc, we can prepare the iron solutions. A different series of standard solutions will be prepared, and as already shown in this video. Similarly, the manganese standard solution will be prepared. And copper as well. So the first step is we need to take 10 gram of soil into 125 ml aluminium flask and add 10 ml extraction solution, DTP extraction solution. We need to add, if we are using 5 gram soil, then we can add 10 ml extraction solution, and if we are using 10 gram soil, then we need to add 20 ml extraction solution. After adding the extraction solution, we need to shake it on the reciprocal shaker for 2 hours. After shaking, um, we need to filter the suspension through a filter paper. Now after taking the filter, we need to analyze for the different micronutrients, and for the measurement of the zinc, copper, iron, we we need to operate atomic absorption spectrophotometer according to the instruction provided for the equipment. Here in the video we can see the atomic absorption. We will prepare the standard curve by using all the series of the standard solution we prepared for each micronutrient. For zinc, we can see how we can measure the zinc. The atomic absorption will give the reading of absorption, because now we are running a series of standard uh, solution, and definitely we are going to draw a calibrative curve. Each standard solution for respective micronutrient will be run on the instrument. After drawing the standard curve, we will take the reading of the sample. After taking the reading of unknown sample, soil sample, its known concentration will be calculated from the standard curve. So the zinc concentration will be calculated according to the calibration curve. I would like to mention that very important point here, that while using the atomic absorption spectrophotometer, you must ensure that the particular lamp, a correct lamp for each element, because the specific element, the cathode lamp is specific for each element. So you make it sure that if you want to measure the zinc, you must make it sure that the zinc cathode lamp is there in the atomic absorption. So after calculating the zinc or the iron, manganese concentration according to the calibration curve, you need to calculate the micronutrient concentration in the soil by following the this equation, where the microbial cations ppm in the soil is equal to ppm concentration of the soil from the calibration curve, multiply with the volume, the total volume of extract in our case was 20 ml, because we use 20 ml extraction solution, so we need to mention 20 ml here. and weight of the dry soil. In our case, we use 10 gram soil, so we will mention 10 gram, and then we will calculate. We will be able to calculate the desired concentration of respective concentration of the particular micronutrient in the soil. Thank you very much.